Okay, so if you are watching the video, pause and do this, and then come back. We're going to go on. All right, so if I want to write an equation of the line, what do I have to do first? Find the slope. Okay, now remember that if I'm doing this as a function, we're talking about rate of change, we're doing all that, we have to put our f of 3 minus f of blah, 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 right? Here, nobody's really asking me for the slope. I just need it, so I don't have to do all that. So just be careful knowing when you should and when you shouldn't. So negative 3 minus 7 over 5 minus 3 gives me negative 10 over 2, which gives me negative 5. Okay, we all good with that? That's your slope. All right, so then I have to pick one of the 2 points. I would imagine most of you picked this one. Did anyone pick the second one? Okay. Why? I'm just curious. There's absolutely nothing wrong with it. You just like it better? Yeah. Oh, that's a good one too. Okay. It's because it really totally doesn't matter. So we would either have y minus 7 equals negative 5 times x minus 3, or I'd have y plus 3 equals negative 5 times x minus 5, right? Either one of them is 100% fine. We all good with that? Okay, so we're going to add one thing to this. And the reason I did not do this on Friday is because I don't know whether or not Delta Math will be okay with this. Probably not. In Delta Math, it probably has to be exactly this because this is point slope form, okay? But kind of the advanced point slope form, I guess. There's a lot of times where you need it. Point slope form is the easier way. I didn't distribute. I don't have to deal with fractions or anything like that. But we still sometimes need it solved for y. So we just do one little thing, not a bazillion little things, and move the 7 over. Legally, I can't just willy-nilly move it over. So this would be like this, and then plus 7. And then this would end up being y equals negative 5 times x minus 5 minus 3. And then stopping there instead. And it's fine. You'll get to, some of y'all will get to a point where you can just write it like this. But I think if I was going to make everybody do it one way, we would still write it like this and then do this, because I think it's safer because it's minus minus. But also, if you just know that y is what it is and x is a liar, I mean, that idea still works. Whatever you got to do to not mess it up. But I would still suggest that probably most of you need to do this because you can get that in your brain and then just change it to that. Okay? We good on that? And I'll show you why. Remember, the whole idea of us going over this on Friday was so that I could approach this lesson today a little bit differently and connect it directly to lines so that there's not a ton of other stuff you have to remember. Okay? We good on this? All right, so you can erase everything, put your markers and erasers back. All right. We also need to talk about data. Amanda. So we have here 2 different types of data, and I know you've discussed this before. We're going to discuss it again. We've got discrete data and continuous data, okay? And both of them are linear, but both of them are not lines, okay? We tend to use the word linear and line like interchangeably, and it's not really 100% interchangeable. Like if I asked you, what is this? And you said, this is a line or this is a linear function. Both of them, 100% true. This linear function, not a line, right? Because I don't have the dots connected. So linear just means kind of line-like. Is kind of what that, I mean, it has a better definition than that, but you know what I'm getting at. So your discrete data, this is cars and the and the cost. So I can sell 1 car or 2 cars or 3 cars or 4 cars. Selling 1.5 cars makes no sense. Would you agree with that? Okay. So connecting the dots here makes absolutely no sense. But if I'm going to go to buy grapes and they're sold by the pound, the chances of actually getting 1 pound of grapes exactly, highly unlikely, right? It's always a little bit off. So cost of stuff, time, weather, all those kind of real world things, those are all continuous because you can have pieces of them. When we're talking about cars or people on a bus or something like that, that is discrete data. So I know you know that there's a difference. I know you've written out domain and range and stuff like that. For years you've done all that. So this is just kind of where we're going with this. We've been talking about a lot of continuous stuff. We talk about a lot of continuous stuff. The equations we just wrote on the table, those are lines and they are continuous. We're going to take what we understand with that and connect it to these sequences with discrete data, okay? So this is going on page 44 when we are done. Okay, so sequences, not new to you for sure. So a sequence, just like a list of numbers, okay, that have some relationship, is a function. So it is a function from the whole numbers to the real numbers. Now, I showed you at one point already, I think, a Venn diagram of number families, right? So we have whole numbers, natural numbers, integers, real numbers, imaginary numbers, complex numbers, all those different things. So whole numbers are like this list right here. 0, 1, 2, 3, 4. They're like the whole things, no fractional pieces, but it includes 0. If I don't include 0 and just start with 1, those are your natural numbers. If I have all my whole numbers and I include the negative ones, those are the integers, all right? And then real numbers could be 1.2, 3 halves, square root of 5, pi, anything like that. Just anything that's not imaginary, negative pi, any of that stuff works. So what we're doing here when it says it's a function from the whole number, so this is my input to the real numbers, this is my output. So I input the whole numbers. My output may or may not be a whole number, but it is definitely a real number. And it could be positive or negative. That doesn't matter. Real numbers incorporate both. So it goes on to explain kind of what I just said, is that this means that we are only able to plug in whole numbers into a sequence, but we can get any real number as an output. Okay? Because the input is the term number. Okay, or basically. So as a result, when we graph a sequence, we will have points, but cannot connect them together. No connecting the dots. It's selling cars, how many people fit on a bus, things like that. We good? Again, those contexts, I know that is not new to you for sure. All right, so we're going to consider this sequence. So I have this sequence here defined by this little equation. Does that look like a linear equation? Yeah, kind of looks like y equals mx plus b, right? But the fact that I have little a sub n and things like that tells me it's not straight up a line, that it is a sequence type of thing. And that a sub n, whatever n is, n goes in here. So if I want a sub 1, I replace n with 1. 4 times 1 minus 3. So that ends up giving me 1. My input is 1, my output is 1. Right? Or if I want a sub 7, that's going to be 4 times 7 minus 3. What's 4 times 7? 28. Minus 3 is 25. Okay. All right, so you understand how that works, right? Your input and output and how it looks a little bit different. Okay, so we have 2 different types of sequences we're going to talk about, arithmetic and geometric. We'll talk about geometric tomorrow. So we're starting with arithmetic today. And so if I have property of what's called successive terms, so if I have like 1, 3, 5, 7, 9, so these are my terms, right? And they're successive, so they're one right after another. I'm not skipping around or anything. That's what it means by successive. ... Okay, so successive terms have a common difference. That common difference is represented by a lowercase d for difference, or a constant rate of change, which is what makes it linear. So the common difference in a sequence is what we know of in a line as the slope. And that's the m. Right. Now, the 2 little equations that you need to be familiar with for sequences are right here with all those little subscripts with n's and k's and other letters. And it's really not that difficult, but the thing is we talk about it a little bit to make some connections, then we don't do a whole lot with it. So when it comes up on the exam, it's been a minute since you've seen it. Even if we review, it's not like other things that we do that's embedded in everything we talk about. And so we're just not using it that much. So it makes sense that we may not remember that perfectly, right? And that's the problem, is that this isn't difficult, but if you don't know that, then that could be a problem for you. Now, I may have one, maybe two people all day long that like formulas. I love formulas. Give them to me. I remember every one I've ever read, ever heard of. All, yeah. If that's you, just keep it to yourself. Nobody wants to hear it because most of our brains don't work that way, right? So instead, I want to tie it to something that you do fully understand. If this is arithmetic, so we understand that we can tie it to a linear function. This looks pretty much like one of the linear functions we already are very familiar with. What does it kind of look like? Which form? Y equals mx plus b. Could you kind of get that out of it? Could it be its distant cousin? Right? They're not twins, but they're distant cousins maybe. So if we can make this into y equals mx plus b. And we'll put the pieces together in a minute. Whose distant cousin could this be? Point slope form. So we know that's y minus y1 equals m times x minus x1. But notice there's just an a sub n over there by itself. So just like we did on that little warm-up, we're going to move that y1 and get y equals m times x minus x1 plus y1. Everybody good so far? Okay. So to get our terms and stuff down for sequences, your a sub 0, which lives right here in this little one, that matches up with what in my line? B, right? Matches up with B. And the a sub 0, that is just your initial value. In a line, we call that B your y-intercept. So if you think about it, when you have a graph of a line, your y-intercept, that's where you start. That's your initial value before anything else happens, right? If we're just talking about positive stuff. All right, so then we have D. That's right here. What is that in my line? M, it's a slope. So what D, like D itself, what it really stands for is common difference. But what we already understand it as is slope, which is M. But the letter could be anything, right? This morning, when I did the warm-up and y'all wrote this form down right here, somebody had, or this form, y minus y1 equals a times x minus x1. So I just walked by and I said, what is a? And first he goes kind of, I said, what is a? And he said, well, it's the slope. I said, okay. And I kept walking and the people at his table was like, no, it's supposed to be m. I said, does it really matter what the letter is as long as he knows what it is and what it does? No. Unless I'm asking you for a and you think that's a or something like that. I mean, then that's a problem. But he knew it was the slope. He was going to put the slope in there. It was going to be fine. So whether it's D for common difference or M for, I don't know why it's M for slope, but whatever, there you go. Okay, we good? All right, so then A sub K. That guy's right there. This is weird terminology, I know. But this is the kth term. The kth term. So if I have A sub 5, it would be the 5th term. You just make it a fifth or a st. Okay. But that matches up with what over here? Y1. That's just your Y1. That's the value that's the Y value that you know. Because when we write the equation of the line, the X1 and Y1, that's the ordered pair that we actually know and that we're using. Okay. Then A sub n, that's right here, right? That is just your output, which is your Y. The n is your input, which is your X. So do you see how all that works? It's all just the same thing. That's all it is. Same stuff, all right? So a couple little notes here. Arithmetic sequences behave like linear functions. Behave like. They're not exactly the same. They are not continuous. No connecting the dots. Increasing arithmetic sequences, so increasing arithmetic sequences increase equally each step. Slope always stays the same. That's what makes it linear. So that's kind of duh. It's linear. So if you're going to tell me it acts like a linear function, then that has to be true. Okay. Any questions at this point? All right, so let's start off with something very simple here. Got a sub n equals 3n plus 1. All right, so over here, we're going to do our input is n, our output is a sub n. We're going to do 0, 1, 2, and 3. Okay. So 3 times 0 plus 1 is 1. 3 times 1 plus 1 is 4. Then 7, then 10, and so forth, right? Also over here, I know that this right here, that represents a sub 0, which also represents my y-intercept, and that's 1. And then your common difference, which represents your slope, is what? 3. Okay. So if we plot this, whether we plot it from the function over here or the or my little table over there, my y-intercept is 1, and then I can count the slope, but I also have this over here, so I can go to 1, 4. Except I can't ever hit the right spot. 1, 4, 2, 7, 3, 10 gets me off my graph. Okay. Do I connect the dots? No, no connecting the dots. This is a sequence. This is discrete data. No connecting of the dots. We good? Any questions? Okay, good. All right, now for each of the following, we are going to determine if the sequence could be arithmetic. If yes, we're going to identify the common difference. So look at A. Do you think A could be arithmetic? If it's arithmetic, what does it behave like? A linear function. Is this a linear function? No. So we're going to say not arithmetic because it is not linear. Right? What about B? Yes. Does that look like a linear function? Yes. So we're going to say this is arithmetic. And what is the common difference? -2. Okay. Everybody good so far? Now, on the next ones, we have to actually see if we have a common difference. What has been a big hurdle for way too many of you when we have data like this is way too many of you have problems adding and subtracting positive and negative integers. And that's not anything I can help you with anymore. I don't know what to tell you. You have to be able to add and subtract or you can't get the right answers. So I got to subtract second minus first. So -2 minus a -7 is 5. 3 minus a -2 is 5. 8 minus 3 is 5. 13 minus 8 is 5. So I have a common difference. Literally every difference is the same. So I can say that this is arithmetic. And D equals 5. Okay. We okay with that? Any questions? All righty. So then let's do D. -2 minus 1, -3. 3 minus a -2, 5. Do I need to go any farther? No, the rest don't matter. Even if the rest are all 5s or the rest are all -3, they're not all the same. You might want to double check that you actually subtracted your numbers correctly, but we did. And so then this one is just not arithmetic. Okay. And I gave a reason right here. My little numbers there are my reason. I showed it. I didn't necessarily say it, and that's totally fine there. Okay. What questions do you have? Anything? All right, flip it over. Okay, so we are taking functional, well, this is all functional, but line-based ordered pairs that we are used to, like X, Y, and we are looking at them in terms of sequence notation, where my input is n and my output is a sub n. Okay, the input is n, the output is a sub n. So it says let a sub n be an arithmetic sequence with a sub 3 equal to 8, d equal to -3. Find an expression for a sub n and use the expression to find a sub 12. There are two parts to this answer. So if you just go in there and do stuff to figure out a sub 12, that's great. Nobody cares. You don't answer the first part. Nobody's looking at the second part. Okay, so even if you already know what a sub 12 is, great. Keep it to yourself because, again, nobody cares. You don't have an equation. All right, so what I'm going to do is I'm going to take it kind of out of arithmetic stuff and put it into XY stuff. So this statement right here, through a sub 3 equals 8, what would that ordered pair look like? What's my input? No. 3. My output is 8. Your input is the n. Your output is your a sub n. Okay, whatever the actual value is. And then this is your slope. So I'm going to write my equation. Y minus 8 equals negative 3 times x minus 3. Then I'm going to move the 8 over. Y equals negative 3 times x minus 3 plus 8. Okay, everybody good so far? No, we're not plugging in anything because I don't have a sub n, and I need a sub n. So a sub n, which one of these is a sub n? X or y? Because nobody asked me about x or y. Y. So this becomes a sub n equals negative 3 times, and x is n minus 3 plus 8. Now I have satisfied the first part of the question, sort of. Okay, say sort of because if this is multiple choice, maybe my answer choice looks like this, but maybe it doesn't. And so I need to be able to recognize it either way. All right. So if you're doing this and it's free response, you stop here because stop, don't do anything else so we don't mess anything else up. But I could have the answer as another form. You could have either one. So if I keep going and I distribute, I'd get a sub n equals negative 3n plus 9 plus 8. So a sub n equals negative 3n plus 17. So basically that's the y equals mx plus b version of it. On a multiple choice, you could have either version. You could have a mixture of the versions. You just got to make sure that you don't get this and go, oh my God, my answer isn't there when this answer is actually there, or vice versa. Okay, everybody good with that? Okay, so now that I have actually answered the first part of the question, now I want a sub 12. That's going to be negative 3 times 12 plus 17. It's negative 3 times 12. Negative 36 plus 17. And what's 36? Negative 36 plus 17. Negative 19. There's my answer. So do you see how to just make that into linear stuff and it's no big deal? Who cares about the k's and all the other stuff? We don't care. Okay. And here's the thing. If for some reason they're like, what is a sub k? They're going to have, if they ask a question like that, they would have something like this written for you. Because if they're going to ask you about a specific variable, they're going to give you the generic thing to look at. But I doubt that would happen because I don't think they're going to give this to you in any form or fashion. I would just expect that. I would be shocked if they did. All right, any questions at all? All righty. Let's look at 4. So a sub n, arithmetic sequence, a sub 2 equals 7, a sub 6 equals 9. I need to find an expression for a sub n and find a sub 24. So the first thing I'm going to do is take my little terms, put them into ordered pairs. So what's this first ordered pair going to be? 2, 7. And then the next one would be 6, 9. Okay. So we're going to go find our slope. 9 minus 7 over 6 minus 2. Right. Equals 2 over 4. So that's 1/2. Okay, we all good with that? All right, so then I'm going to write the equation. I need to pick one point. Does it matter which one? No. But here's my suggestion to you, because is this easy? Yes. Is this where we make our mistakes on easy stuff? Yeah, I totally messed up the slope last period. I put the backwards. That's why you should label and stuff. But anyway, we mess up on ridiculous things. So you pick one. And if I'm going to pick this first one, not only am I going to circle it, I'm going to mark out the other one. Because a mistake that I see too much, enough that I feel like I have to say it, is you accidentally taking x out of one ordered pair and y out of the other. Do I think you really think that's how you're supposed to do it? No, but you look down and you look back up and we just grab the wrong number, right? So do those sorts of things. That helps you with your careless mistakes. All right, so then I'm going to do y minus 7 equals 1/2 times x minus 2. And then y minus, oh, nope, my whole point is to move that over. Y equals 1/2 times x minus 2 plus 7. So now I'm going to make that into a sub n equals 1/2 times n minus 2. Don't mix your x, your n's and your x's and stuff, plus 7. Okay. Everybody good with that? Okay, so that's a sub n. Check. Now we want a sub 24. And if I needed to do that in a different form because it's multiple choice, I can. But if I don't need to, I'm not doing any of that. So I'm going to get 1/2 times 24 minus 2 plus 7. Let me tell you something else weird I see. Because one thing that y'all are really good at is trying to make things as difficult as possible. At this point, do not distribute that 1/2. That's ridiculous. I see people do that, do it correctly, but I don't know why in the world you're doing all that. And I know go ahead and combine those, then multiply, right? Doesn't that make sense? But I see those things, so I feel like I need to say them. So this gives me 1/2 times 22 plus 7. So a sub 24 equals 18. What questions do you have? Anything? We good? Yes? All right. All right, so several terms of the arithmetic sequence a sub n are shown above. Find the expression for a sub n and use the expression to find a sub 17. All right, so this time they gave me a graph. They told me it's arithmetic, so I don't have to figure that out. Do I know my y-intercept? Yes, I straight up know it. I'm not guessing it, nothing. It's right there, right? So I know that b is equal to 8. Now I need to figure out my slope. First of all, is my slope positive or negative? Negative. Okay, so now that I got the negative down, now I can just count. And since it's linear, I can count between any 2 points. So if I'm here, I can go up 2 and over 1, so it's negative 2. So now you can use your former favorite of y equals mx plus b and do y equals negative 2x plus 8. That is when it's good to use that one, okay? Because we're not trying to force it in there. But again, nobody asked me about x and y, and I can't leave it like that. I need to make this into a sub n equals negative 2 times n plus 8. There's my a sub n. Then I can find a sub 17 to be negative 2 times 17 plus 8. Tell me, before we actually do the calculations or anything, tell me something you already know about the answer. It's got to be negative, because if it's linear and we're already here, it's got to be negative. So if my answer is not negative, I did something wrong. Doesn't guarantee that it's right, but that's one way to catch yourself. What's negative 2 times 17? Negative 34, good. Plus 8, a sub 17, negative 26. Okay. What questions do you have? Anything at all? All right. So then I'm going to give you your assignment, but look at this. Today, this only goes with 7 through 12, so you're not going to do the top. Don't start on the top and be like, how am I supposed to know this? You're not yet, because we're not done. But you can do 7 through 24. 7 through 12. You can probably knock it out before you leave today.